Greetings, I'm Athara Patawar, and today the project we are going to show you is road quality mapping and navigation. Next. The aim of this project is to develop a machine learning model that predicts the presence of potholes on roads in India, as well as the road conditions of the roads, from the data collected from cameras and sensors mounted on select public vehicles, and to use this data to recommend the best route to users along with the traffic information, so that the users will find the best route according to both time, traffic, and the quality of the road as well. It will also help for the government to prioritize the road development because we will show an analytics dashboard where the government can see which roads have the most traffic as well as the most number of potholes or the worst road conditions, because those are the high priority roads to uh, develop. Next. Now, the basic motivation for this project came from traveling on roads. So basically, everyone travels on road, and everyone in India faces the issue of potholes and bad road conditions, mainly because the road network is quite big. So the government has a hard time coping up with the development of these roads, and the seasons like monsoons and other weather conditions mean that the road conditions deteriorate very quickly. So a system is needed that dynamically and in a real-time way shows the road conditions and the potholes in each area, because the potholes and the road conditions change very quickly, because if there is a flood or rain in one area overnight, that there are multiple potholes and bad road conditions suddenly. Now, to solve this problem, we first did a literature review. So we saw multiple papers on IEEE. We read through them, close to 20 to 25 papers, and what we deduced is many of the papers only focus on the sensor-based approach. So a sensor-based approach to this would be using the onboard accelerometer, gyroscope, and speed sensors to determine the potholes and the bad road conditions. And then a few number of research papers focus on the image-based approach. So the image-based approach is basically using a camera that is mounted on the vehicle to detect the potholes. Now there are pros and cons to both of these. Like using only the computer vision model, what happens is it doesn't work in the night time, and it doesn't tell you about the road conditions, it would just tell you about the potholes. But the pros of the computer vision model is it tells you the exact number of potholes, which is useful. And it also has the ability to capture images to send to the government if they want to review the conditions of the road themselves. And the pros with the sensor-based model is it works in low light, but the cons are majority of the drivers avoid bad road conditions and avoid the potholes. Like if there's a section of the road which is bad or where there are potholes, majority of the drivers will avoid that. In which case, the potholes or the bad road conditions would not be covered by a model, which is why we need the computer vision model. Now, our approach merges both of these models, that is the computer vision model as well as the sensor-based models. So during the day, which is majority of the time, the computer vision models will be working, and during the night time, if we want to map during the night time, the sensor-based models will be working, and there are two sensor-based models in our approach. One model detects the potholes, and one model detects the road conditions. The model detecting the road conditions will be working throughout, like every time in the background, but the model which detects the potholes will only work during the evening or low light conditions. So this is a complete end-to-end reliable and robust solution to detecting these potholes. Now, these devices with the cameras and the sensors like accelerometer and gyroscope will be mounted on public vehicles like buses, auto rickshaws, or garbage trucks, because these vehicles go through the same road multiple times in a day, and they go through a particular area every day. So these vehicles are the perfect ones to get real-time information from. Now, the existing research papers for the computer vision models also use the older YOLO versions. That is, you only look once algorithms, and we will be using YOLO V8 model, which is giving a much better accuracy. In our current testing, it is giving an accuracy of 95.2%. The older versions were giving an accuracy close to 50, 60, or 70%. We even tried different versions of the YOLO V8 model, like YOLO V8 S, L, N, etc. But the M version suits the best for our needs. And we even tried YOLO NAS and Mask RCNN as well. But the results they have given are not up to the mark. We even tried Detectron 2 models, but same, the results we got are not up to the mark. Now, Mohammed will explain how the model will work in the actual backend.
So I will be showcasing you the backend part of our Flask server. So I'll be sending a request to /predict and I'll select a portal image from my PC. And this is the coordinate. We are pretending to get this coordinate right now. And if I send the request, our model successfully identifies the potholes in our image, and it gives us the confidence of the pothole, assigns the ID to pothole, and this is the rectangle in which the pothole is enclosed in the image, and it returns the coordinate back and the number of potholes in the image. Now, if I want my image to return as it is with marked pothole where it is, so I will add a return type to this request and then I will send it. So our backend returns us an image of with all the potholes marked in it.
Now we'll take a look at the backend infrastructure of this application. So firstly, we are planning to host our entire backend using AWS, which will be acting as our sole cloud provider. The flow of the admin side is pretty straightforward. The admin is first authenticated through the AWS Cognitive User Pool. The admin is then able to upload and save custom images along with the respective coordinates through our ST bucket, in our ST bucket, which will be eventually passed through the model. If pothole is detected in those images, they are directly registered in the database. All three models, the gyroscope, accelerometer, and the image processing model, are containerized and set up for inference on our EC2 instance, which is like a virtual VM instance provided by AWS itself. During the production phase, we'll be having a custom application on the worker nodes, which will be sending live images, the GPS info for the coordinates, the motion sensor data to our backend. The image and the motion sensor data are processed parallelly by the server, and if potholes are detected, they are written in our database. The register potholes can then be visualized on the client side, and our mapping algorithm will be trying to actively avoid these potholes. The CloudWatch service is offered by AWS, which gives us like the error logs in case of any failures or exceptions. Next slide, Mohammed. This is the serverless approach. It has the same logic, but we are using like serverless Lambda functions instead of a dedicated backend. Next. This is the flow of the client interacting through the user interface. The user is first authenticated, and based on the user's requested route, the database is first queried to get all the potholes that are present in that particular route. And based on this data, the most pothole-free, the most quality route is mapped and displayed for the user. We are going to use Google Maps API for real-time traffic information and to visualize the custom route for the user. So that was the client and the admin flow of things. Now we'll take a quick look at the UI of our UI. Next. So this is a UI. It is like a simple minimalistic design, and it has a easy to use user interface. The user will be first selecting the start and the destination and specify the mode of transport. And considering the real time traffic data and the pothole inferences, we'll be providing two routes. The first one will be the most time efficient route, and the second one will be like the most quality route from our source to destination. Yeah, so now we'll take a look at the future scope.
So now I'll be explaining the future scope. In the future, we plan to expand this endeavor to the rest of India so that we can scan every single road and we have this network of public vehicles, certain selected public vehicles like buses or garbage trucks that go and scan every single area while doing their normal tasks every single day, so that we can have a map of the entire India with the road conditions of every road, the every single pothole that exists in India, and the government can see a high level analytical dashboard of all the areas where there is a high traffic as well as there is high number of potholes, so that they can prioritize the development of those areas and those roads first before others. In conclusion, we aim to create an end-to-end system, and unlike the previous research papers and projects that have been done, we are not just ending at the machine learning models and not exploring just one machine learning model, but to make our system more robust and more reliable, we will be combining two machine learning approaches and in total three models. One model for the detection of potholes, one for detection of potholes using sensors, and one for detection of road conditions. Using all this together creates a end-to-end machine learning model that is capable of dealing with any situation and mapping any kind of road. And we are combining this with an application that is highly reliable, highly secure, and highly scalable, so that the government can use it for analytical purposes and the end users can use it for navigation and mapping purposes. Thank you.